Okay, for the 5.4 ready, set, go, please, please, please pause this video and make sure you have tried this before you look at these answers, okay? These are short, identifying quadrilaterals. You should be able to try this. Do the entire ready, set, go, the parts you can, read the instructions, and then go ahead and play this video, okay? All right, let's see how you did. So we're looking here at what quadrilaterals, identifying each quadrilateral as a trapezoid. So like we had a trapezoid right here, a parallelogram. You're going to notice that some of these identify as more than one thing. A rectangle, and a rhombus, and then there's a none, there's a kite. That's not even a mathematical term. And none of these were identified as a square. Okay, so just take a quick peek at these. How would you do? Now, why is something a parallelogram? It's because you have two sets of parallel sides, flat out. That's all you need to make parallelogram. So what's the definition of rectangle? Definition of rectangle is 4 90-degree angles. And so here we were told that there's a 90, there's a 90. So you know you have rectangle and you know you have parallelograms, etc. Rhombus just needs 4 same sides. We got that. And we know that it's a parallelogram from the 2 sets of parallel sides. Trapezoid has only 1 set of parallel sides. Parallelogram, rectangle, rhombus over here. Oh, this one is a square. I just looked at the definitions here. This one has 4 right angles, 4 same sides. It is a square. So let's go make that a new color. All right, kite. Did you try to give that a weird name? And then parallelogram is all that the last one is. Okay, so hopefully you're getting good at recognizing those symbols. Coming up next, they wanted us to identify parallel segments. So part A, after a translation, corresponding line segments in an image and its preimage are always parallel. So looking here to the right, which segments were parallel? It wanted you to say segment FH was parallel to F prime H prime. Segment GE was parallel to G prime E prime, and so on and so forth. Do you see all the matching parallels now? After it was translated. Okay. This one over here, so this one was the translation, by the way, over here. This next one is after a rotation of 180. Do you remember this? After a rotation of 180. Corresponding line segments of a preimage and image. So it's saying that F, H, and FH, EG, and EG, FJ, and FJ, EH, and E prime H prime, parallel, and finally, oops. Okay, so there's the parallels of that whole one. So see how they wanted you to write out what was parallel, and I also asked you to highlight to visualize those. Okay? After a reflection, which line segments? And then the answer is none of the line segments in the preimage are parallel to the line of reflection. And so in this case, since none were parallel to start, the one that looks the closest is maybe this guy, but see how it's not quite parallel, it's kind of leaning in. So since none were originally parallel, none are parallel after. It's only when something is parallel to the line of reflection to start, like our triangles that we did the other day, then that would make it parallel again after. So in this one, it was kind of a trick question. None started out parallel, so none are parallel now. Okay. All right, next, for each pair of triangles, write a triangle congruent statement and justify your statement by identifying the pattern you used. Then justify the triangles are congruent by connecting corresponding vertices of the preimage. And so here we go. Triangle CDB is congruent to EFG. By side, 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 see the markings. And then they wanted you to connect the corresponding line segments. Okay, so pause the video now, go try the others. Triangle FEG is congruent to JLH. By side angle side, see the markings, and then go ahead and connect the corresponding parts. See those parallels? Triangle GFH congruent to JMK, and then connect, that's by ASA, see the markings, and then connect the parallels, the corresponding parts. Triangle FEG congruent to JHL, by side angle side, see the markings, and then connect those corresponding parts. And that's it.